Second element of a bad metric is if they create competition. So if you have two teams and the team that raises the most defects is going to get a reward, or the team that writes the most code, it doesn't mean that you're writing the best code or the code that should be written, or anything at all about the purpose, quality, or value of the code you're writing. It's just a number, and you are going to hit that number or try to get the biggest value so your team can get rewarded. My friend Hillary Weaver Robb said in a presentation she did, I write my bug reports as if they're going to be read by a mind-wiped version of myself. So in other words, if I read this tomorrow as if I don't know what I know, could I understand what it's talking about? So what goes into a good bug report? It's, one too many. My acronym is people working. You clearly and concisely describe the problem. Make sure you have an example, steps to recreate. The Oracle, what are you using to determine if it's a bug or not, and why you think it's a bug? You want to be polite. You don't want to have emotion or blame in there. Literate, you want it to actually read like a story, have proper spelling and grammar. You want to extrapolate what else might be related, and if there is a workaround, include one. Test reporting. So, test reports typically are horrible. I have almost never, I shouldn't say that. I've only seen maybe 5 test reports of when I first show up at a client as a consultant, or when I first get hired into a new company and I look at the test reports they're generating. It's a very small number that I consider to be good. With UI automation, what I have found is it's often used far too much. It's usually created by non-developers, people who were testers, didn't know code, and then because they were told they had to learn how to code, they learned how to code. But if you take a tester away from testing and have them write automation, if they aren't already computer scientists or know how to write code, you're likely losing a good tester and gaining a bad developer.
So once again, welcome all of you to this webinar with Paul on the testing profession, the good, the bad, and the ugly. Before going into the session, I would like to give a huge shout out to BrowserStack, our exclusive sponsor for all community events and premier sponsor for conferences. Because of them, we are able to do all of these events, and we are able to reach out to you and help you upskill yourself. Our one thing, our community. So if you want, join in on Discord. We have a lot of things on our Discord channel about work, testing, life, balance. We generally chat with each other there. And the link of the community is, we are dropping that in the chat. So do join us there. And now finally the session. I would love to invite Paul on stage. He has around 27 years of experience in software testing. He specializes in adapting testing methodologies to reduce waste and to increase effectiveness and efficiency. Paul is one of the 5 instructors of a rapid software testing course developed by James Park and Michael Bolton. He has also done a session with us before on Better Bugs Report, which was loved by the attendees. So I would love to call Paul on the stage. Hi, Paul.
Hey.
Yeah, hi.
Let me see if I can share my screen, because I just did something that might.
Sure, you can try it once.
Hi, everybody. So a bit of my background, actually, you've already heard that, so I'm just going to move on. There's a few things that I want to cover today, talking about good, bad, and ugly, mostly bad and ugly, and things that I would like to see different. So we're going to start with language. And I see this on LinkedIn. I see it, used to see it on Twitter when I had an account, but I've deleted that. But people often use language in non-precise ways. They complain about people pointing out that they're not using language well. And they often say, you're just arguing about semantics. which is exactly correct because the definition of semantics is the meaning of a word, phrase, or text. So that is exactly what we're arguing about. So the problem that I see about poor language is it can lead to confusion and misunderstanding. This XKCD comic, I think, is fantastic to show it. It's quoting Humpty Dumpty. When I use a word, it means just what I choose it to mean, neither more nor less. And then the lady says, I wonder what all those words you just said meant. Maybe you're telling me I can have all of your stuff. Wait, no, your car too. Thanks, gosh. So without having an assigned meaning to words, language actually falls apart and becomes meaningless. So now, all that being said, there is a time and a place to point out sloppy use and errors in language. You don't want to call people out in a meeting. It's much better to have thoughtful, polite, careful conversations with them, usually in private. So some words that drive me nuts, even though they're used a lot. And notice now that you're more aware as to why these drive me nuts when I tell you, you'll probably see them popping up all the time. And hopefully, as an entire community, we can stop being called quality assurance as an example. Because as testers, we cannot assure quality. The only thing I can assure you is that there are still bugs in the software that I haven't found. So if somebody asks me what my assurance level is or how sure am I that I found all the bugs, I can tell them that I am 100% sure that I have not found all the bugs. We don't call developers bug-free coders, so I prefer just calling ourselves testers. Some people still use QA and switch it to question asker or quality advocate. That's okay, but I still just prefer tester. Next word is best practice. The best practice, by its own definition, it's something that cannot be improved upon. So if I have a best practice, it's going to inhibit improvement on that practice because I'm already calling it the best. If I am of a position of authority, like a VP, a director, the CTO, and I say, hey, here's a best practice for doing that, people are going to be very hesitant to want to prove me wrong and to show improvements. Plus, what works well in one situation and one context may not work even at all in another one. So I prefer, it's a lot longer than best practice, but it's a good practice in this context. Other words that drive me nuts, automated testing, because to do testing, you need to have awareness, you need to be able to explore the product, you need to be able to think critically, and automation does none of those things. It just follows through a series of rote checks, so it's more automated checking, and yes, that doesn't open up the can of worms of difference between checking and testing, but I think it is an important difference. Manual testing, as opposed to just testing, it's like saying manual coding or manual attending a meeting. To actually do testing, you need a human to do it, so it's all there. The testing versus checking, people who refer to checking as testing, and also to expand on that, there's a lot of people, especially people paying the bills, finance people, who think that testers can be replaced with automation, and that is not true. Having a testing phase, and my PowerPoint just died. Fantastic. There'll be a brief pause while my PowerPoint reboots. Sorry about this. And I still have the spinning rainbow of death. Having the words testing phase, a testing should occur throughout the entire project and not just be a separate phase. And then ad hoc testing, usually referring to what people think of exploratory testing, and usually in a derogatory or it's a simplistic way. Oh, you're just doing ad hoc testing, meaning you're doing sort of random testing, when in reality, ad hoc means to this, as in for a purpose. It does not mean random or chaotic. So someone, when the government puts together an ad hoc committee, it doesn't mean it's a random collection of your parliamentary members who are randomly walking around trying to decide something. They are put together specific people for a specific purpose. So it actually means something correct, but it's used usually referring to random or chaotic. The next thing, bug reports. I already, as previously mentioned, I did a presentation on this, so I'm going to go through this really quickly. If you have a bad bug report, it wastes time sending things back and forth, and a bad bug report also lowers the image of the tester and the testing team. My friend Hillary Weaver Robb said in a presentation she did, I write my bug reports as if they're going to be read by a mind-wiped version of myself. So in other words, if I read this tomorrow as if I don't know what I know, could I understand what it's talking about? So what goes into a good bug report? It's, oh, shoot, one too many. My acronym is people working. You clearly and concisely describe the problem. Make sure you have an example, steps to recreate. The oracle, what are you using to determine if it's a bug or not and why you think it's a bug? You want to be polite. You don't want to have emotion or blame in there. Literate, you want it to actually read like a story, have proper spelling and grammar. You want to extrapolate what else might be related, and if there is a workaround, include one. Test escapes. So this is happening less and less, but in some ways, but also in other ways, a little bit more. If there is a bug that escapes out into the field that everybody missed, automation missed it, testers missed it, sometimes I have seen multiple companies who say, we need to have a new test that tests for that exact thing. But having a check for every thing that's found could be a waste of time and effort. It's like a zookeeper that keeps checking that the gates that already failed and let the animals escape to make sure those ones are now fixed, even though there's no animals left because they escaped, instead of looking around for other areas that might be failing. So if it's a matter of a simple unit check that the developer can write and it gets checked all the time, that's great. If it's going to be something that's either time consuming or difficult to maintain or having a human do it, then it's likely not really worth it. Unless it's a critical path or it's happened multiple times, could be revenue impacting or otherwise deemed important enough. Alrighty, metrics. So metrics is a personal pet peeve of mine. I have seen metrics used so outrageously badly throughout my 27 plus years in testing that it's, sorry, that was the definition of metric. You don't need to know what that is. The third one is very long and complicated, which is usually representative of what people think their metrics are telling their consumers. Here's a big amount of complicated things that are summed up in a single number. I have presented this definition to well over a few hundred people, and only 2 people have come up to me and said they understood this definition. Meaning the metric is, this definition of metric is potentially misleading and dangerous, just like most metrics. A gentleman named Charles Goodhart back in 1975 stated this: any observed statistical regularity will tend to collapse once pressure is placed upon it for control purposes, or stated more simply, when a measure becomes a target, it ceases to be a good measure. So as an example, if you are a tester and you are tasked that you must raise 5 defects a week, or you must execute 10 tests a day, or any target that you must write 50 lines of code per hour or some other metric. Any metric that has become a target, it ceases to be a good metric because people are so clever at meeting the target by doing a whole bunch of actions and activities that are determined to be, or that are likely to be detrimental to the end goal. So, what makes up a bad metric in my mind? Well, if it's taking um, a measurement or doing a comparison between things that are inconsistent in size or composition. So in other words, if I say a test case, and we're talking about old manual test cases, do this, expect this, do this, expect this. I have had some of those test cases that I could execute in, let's say, 2 or 3 minutes, most. I've also had some that take over a week to execute, and yet those are both counted as one in the chart, even though one is a few minutes and one is multiple days. So it's like asking, I'm about to move, and somebody says, well, how many containers do you need for all of your possessions? Well, how big are the containers? Nope, just I need a number. How many containers? Well, are they tiny or are they the size of an ocean liner? If those can't both count as a single container. Oh, they do. How many containers? Oh, I need 8. It doesn't mean anything. The second element of a bad metric is if they create competition. So if you have 2 teams and the team that raises the most defects is going to get a reward, or the team that writes the most code, it doesn't mean that you're writing the best code or the code that should be written, or anything at all about the purpose, quality, or value of the code you're writing. It's just a number, and you are going to hit that number or try to get the biggest value so your team can get rewarded. If I have to do a certain number of things in a week and a coworker comes up and says, hey, can you help me? I am completely blocked and you're the only one who can help me. And I say, well, I'd love to help you, but I'm way behind on hitting my artificially enforced goal, so I can't help you. I have to meet my goal, and then I can help you. And that's not good for the company. It's likely much better for you to not meet your goal and instead help this other person who is otherwise going to be sitting there not being able to do their work. And it's especially damaging if there's any compensation involved. The third element of a bad metric is one that's easy to game or one to circumvent the desired intention. So it's easy to be improved upon by an undesirable behavior. Things like pass rate. If I have automation and it's running, and for whatever reason it's not 100% green, or not talking about a CI/CD pipeline or a level of unit test, but if I have my UI level tests and they're running at, I don't know, 90% as a pass rate, and I need them to be running at 95% for, again, an artificial goal that's been put in place by my management. Or if you work in telecom in North America, the testing standard TL9001 actually demands a 95% pass rate on your test cases. To my knowledge, it's the only regulated industry in North America that has a stupid metric that's being imposed. But if I have to meet that 95%, people are going to do things that undesirable to meet that number. I did work in telecom for a long time, over 17 years, and I did have an 89% pass rate one release. And my project manager came to me and said, is there anything you can do about this, Paul? And I said, well, what do you mean? And he said, could you execute more tests that you know will pass so that your percentage goes up? And I said, I am not going to do that. And we had to fill in paperwork, an exception why we didn't meet the 95%, but I wasn't going to game the metric, even though I know it's an easily gameable metric. Something else that may or may not have happened while I was there, I cannot deny or confirm, but I do seem to recall that the day before we released, we may have had some critical defects open and more than 10 majors open. And the day we released, we never had more than 0 criticals and more than 10 majors. A day or two after, we may have had those counts again, but again, TL 9001 states you can't have any criticals and 10 or less majors, so we made that happen by gaming the system. The fourth and last part is you can try to summarize far too much information in a single number. Something like code coverage, path coverage, again, pass rate, the number of test cases. If I have 10,000 test cases that are passing at 99%, am I better than a similar project that has 100 test cases passing at 90%? I don't know. I can't tell you what's the 1% that's failing in the one with 10,000. What do those 10,000 tests do? What do they cover? I have no idea, but boy, 10,000 sounds like a big number and 99% sounds pretty darn good. So I don't know. But if you then investigate into a story and look at, which I'll get into in a little bit in a future section, when you try to tell the story of the status of the project, the one with 10,000 tests and a 99% pass rate, the one failure, to fix it, we need to re-architect our entire system, and it's likely going to take us 2 months. The one that has a 90% pass rate and only 100 tests, the 100 tests have a better coverage because they're well written and well thought out, and they cover the vast majority of the project. And the 90% pass rate, okay, so we have 10 tests that are failing. We know why they're all failing, and we're pretty sure by the end of the day tomorrow, we'll have fixes for all of them, and we'll start retesting then. So now which one's in better shape? Now that you have a slight story around it, it's clear that the metrics were not very helpful. So what do bad metrics do? They promote bad behavior. I've already covered off a lot of these things. Test reporting. So test reports typically are horrible. I have almost never, I shouldn't say that. I've only seen maybe 5 test reports of when I first show up at a client as a consultant, or when I first get hired into a new company and I look at the test reports they're generating. It's a very small number that I consider to be good. The bad test reports that I see, often it's a summary with a huge focus on metrics. I know at a bank that I consulted at, they would have all of their test cases in ALM and all of their pass rates, and every test case would be a 1, like count as 1 item, and a pass-fail rate. And they would show the burn down of execution over the amount of time, and they would click a go button, and it would print out these beautiful charts that would show the burn down, and it would show the pass rate and how many are left to execute. So pie chart of, passed, failed, and not executed. And the report looked amazing. And every release, and I got this from the VP who had previously been executing these, every release, it looked like they were ahead of schedule. They had, because it was a bank, they had a pretty long testing cycle before anything went live. Understandably, you don't want your money to be at risk. And during that test cycle, they were always ahead of schedule at the beginning of it. And then as they got towards the end, and all the easy short test cases had been executed, and the only ones left were the big, complicated, difficult ones, the execution rate dropped right off, and they went from being way ahead to being late every time. And because they just relied too much on the metrics and not enough on how much effort there is and what's our coverage so far. Bad test reports also give executives a false sense of test coverage by having large numbers and high pass rates. The difficulty of good testing is hidden by these large fake numbers. It's also hidden by having large numbers spewed out by automation. The dangerous message to the executives is something like, hey, our pass rate's at 96%, our code coverage is 100%, and our feature specification coverage at 100%, ship it. But without the, what's our test coverage actually at? code coverage at 100% is not the same as having tested your code thoroughly, but 100% code coverage can be achievable with really simplistic, not very effective tests. So, what should go into a good test report? An executive summary of the status in words, not using numbers. The testing coverage, especially what wasn't, oh, look at that, these weren't in order. A brief description of the testing effort and a test coverage. I would suggest you use a release coverage outline mind map, which I'll show you an example of. The status of the risks, a list of show-stopping bugs and important bugs, not counting them. I don't care about the count. I want a list of them with a brief description of them, preferably with a impact assessment of them, how, if and when they're going to be fixed before we release, and if you have other bugs that are warranted to be in the test report. All of those things above help tell a compelling test story about your testing. So what do I mean by a story? You want to talk about the status. How did it fail? How might it fail in ways that matter to your various clients, your stakeholders? How did you test it? So what you did, what you're not going to do, that's also important. That can be summarized fairly well with a really good release coverage outline mind map. And a story of how good was your testing. So what did you do as a tester to consider or to influence your test approach? What did you test? What didn't you test? And why? What were the risks? How testable was the product? And you can verbalize a lot of this. It doesn't necessarily have to go into a slide deck. If you're writing a long Word test report and you're not able to present it, then I would suggest you put that information into the test report itself. Otherwise, you can cover it verbally as you go through the slides. So I have taken an actual test report from a not too long ago company I worked at, and I've just anonymized it so it doesn't identify the company, but this was actually the test report. It had an executive summary in it. We have an overall status as green. It could be yellow, red. If you have colorblind people on your team, you may want to use shapes to go with it. You could go with a red, maybe a red octagon for stop, a yellow triangle for danger, and a green square or green circle. And then the executive summary says it's in good shape, ready to go live. What the actual release is focused on, and then all the bugs that we found for this were fixed and retested, and no bugs in previous releases are going to be fixed as part of this release. This is the very, very high level description of the testing that we did, so that as an executive, I can look at this and I can grasp what it is. If I want more detail, I can look at the mind map, which is on the next slide. This test coverage legend is, I've been using this, it was helped develop the wording. I've tweaked it a little bit, but it was mostly developed by Sue Finley, who was my VP of quality when I was at Metadata. Eric Pregler and me came up with most of this wording. Eric and I were directors under Sue, and the bright red, and hopefully the colors are showing up okay. The bright red means we haven't tested at all. The dark orange, it's a sanity check. We're doing 1 or 2 happy paths. That's a lot of existing automation is at that level. The light orange is more than sanity. You're doing some error tests and a few more happy paths. Good detailed test cases, good automation would be at that level. Yellow, typically you're not going to be able to achieve yellow with automation, or at least not cost-effective automation. This is where you're getting into increasing the variety and complexity of the paths that you're testing and the error paths, but still focusing primarily on what most people are going to be doing. And then light green, you're getting into some corner cases, some of the weird stuff, state coverage, error coverage. And then dark green, which I think I've only used a couple of times in all the mind maps I've colors. That's where essentially it's thorough testing. You've done a lot of really, really good testing. Very difficult to achieve. And this is an image for that data analytics thing that I was talking about. It was tested in primarily yellow. We didn't do much in the way of end-to-end testing. So we did some really simple sanity testing. Anything with the white text is sanity tested. Anything with the red text is that we don't have any coverage at all. So it's unfortunately a bit difficult to tell the difference between the two. Then I list the bugs. These ones were all from previous releases that are not being fixed. I list some questions and concerns we have, like we don't know what our priority is moving forward, and the reason that we had a little bit of lack of coverage is the requirements and data points were unclear until late in the development, and so on. And then a list of risks and their impact and how we feel about them, and then supporting materials with links to more detail if people want it. And that was the sample test report. And I know I'm already, okay, we're doing all right. I did start late, sorry about that. I'm probably gonna end late. Hopefully it's not too late for your everybody there. So last thing I want to rant about a little bit is UI level automation. I'm not talking about unit level or API level automation, which is where a lot of the good coverage can get you, and where like business logic can be tested at that level. Hopefully when you're at the UI level, you're primarily focused on the connectivity, the interoperability, and less about testing business rules. Hopefully those were tested at a easier to maintain, less cost version of the automation. But with UI automation, what I have found is it's often used far too much. It's usually created by non-developers, people who were testers, didn't know code, and then because they were told they had to learn how to code, they learned how to code. But if you take a tester away from testing and have them write automation, if they aren't already computer scientists or know how to write code, you're likely losing a good tester and gaining a bad developer. Don't take any of that personally. If you are in one of those situations, you can get good at doing both, but I have seen a lot of times where you're not really helping the company as much by writing automation as you would have been doing if you stayed being a tester. So UI level automation, it is likely not going to increase your coverage, decrease your cost, save you time, allow you to reduce headcount, unless you also increase risk. And that's the part that the people who are saying, we're going to fire all of our testers, or all of our testers are going to be writing automation now, we don't need testers for a CI/CD pipeline, everybody's a developer on the Agile team and nobody needs to test anymore. That is all fallacy. It is not the intention of the people who created the Agile Manifesto. It is not at all what will get you into a good situation with your product. If you are relying on automation to be replacing humans and you don't have enough human testers actually interacting and using the product, you are going to get in trouble as a company, because automation only checks certain things and can't think, can't reason, can't be creative, things that humans can do. However, automation can give you a decent sanity check of your product, and it can execute typically in much less time than a human performing the same checks. But the key word there is execute. It can execute in less time, but it doesn't check anywhere near, not even close to what a human can check doing the exact same thing. Human's going to take longer, but a human, because they can think, they can reason, they can be creative, they can do a lot more than the automation. So at Nortel Networks, when it was still a thing, it's a Canadian company that went bankrupt in the early 2000s, but they had a system test team that had raised 1,260 bugs over 1 year that were attributed to scripts, whether it was an automation script or a human executing it. And honestly, at Nortel back then, it was mostly humans executing it. The analysis of whether they were found by the script itself or a vigilant tester was done. And if it was found by the script, that means the script said do A, expect B, and B didn't happen, or A couldn't happen. Something that the script actually, following the steps of the script, found the bug. Or a vigilant tester who was following the steps of the script and noticed something else. The findings were that 70% of the bugs found were found by a vigilant tester. So in other words, they would not have been found at all had it been done by automation. 70% of 1,260 bugs would not have been found if that task had been automated to what the script says to do. Keep that in mind next time somebody says automation's going to replace testers. So if we consider your software as the United States of America and the paths from the cities are the features and the highways are the paths between the features. So the paths that your users are going to use to go from city to city. This was back in 1907. Apparently, if you lived in North Dakota or down here in Mississippi, you're probably not having a car because there's no highways there. As we move along, this one was from 2012, 2013. You can see there's an awful lot more highways. And as your software grows, the earlier you are in the development, first few years of your product, there aren't very many cities, aren't very many highways. Then your product tends to grow and grow, more microservices, more paths, more ways people can get from New York to LA, and so on. It gets complicated. So a big problem about all testing is there are more roads than we can possibly test. As we zoom in, it looks like Denver, the feature Denver only has 5 roads into it. That's cool. I can test 5 roads. But when you get even closer, oh wait, there's more than 5 roads. There's all these other roads here. Oh my goodness, now holy, this is too complicated. I can't test all of this. There's too much. So it is difficult to have automation that's going to check all of those paths. A large insurance company in America, they had a decision that was made to write an automated test for every written requirement that they had. Why do you think they did that? To catch more bugs, to increase their coverage, to future-proof the product, to show thoroughness, to reduce the headcount of manual testers, to make management feel better. All of those reasons are probably why they did it initially. But what ended up happening by writing, and this was UI level automation that they were writing for every written requirement. This was not unit test. And this is a true story from 6 years ago. When I analyzed their testing, the framework they had, it was a Selenium-based framework. They had their own framework written on top of that retried. It could compensate for bad networks because there was offshore teams executing the tests. It was modular. It was all the calls were dereferenced, meaning I didn't have my login credentials. I called the login routine. Everything was done really well with the automation framework. They had over 2,500 scripts, and the testing all of the written requirements they had, not all of the requirements, just the written ones, and any bug that did not contradict a requirement was not a bug until the requirement was created, and then they could enter a bug. So if I found a bug and there's no written requirement, I had to first ask the product owner to write a new requirement, and then I could raise a bug against that requirement. I'm not kidding. I wish I was. So when I analyzed their testing situation, they had 13 outsourced testers who took 2 weeks to execute those 2,500 tests and investigate all the failures. About 40% of the scripts failed on each execution. They would get re-executed, and if they passed, then it was deemed no problem. Yes, there's a problem with that. If they still failed, then they got deep investigated. They have to figure out if it was a script problem or if they had to raise a bug. And on average, this team of 13 testers found 6 defects a month, or 6 defects per roughly 1 person year of testing. I pair tested with the product with the senior tester for 20 minutes and found 5 bugs. So in less than 1 hour, I found 5 bugs. In a year, they found 6. So going to go through these quickly. I've already covered most of them. There's more kinds of problems than automation can be programmed to recognize. If we go back to the highway analogy, we might be looking for potholes. So that's what the automation is doing, is looking for potholes. But what it doesn't see is there's a stalled car off to the side of the road, or the barricade is missing, or the bridge is out. It's just going to go along and look for potholes. That's all it can do. It's only going to recognize what it's told to recognize. So a vigilant tester can evaluate a huge amount of inputs and outputs and different code paths. There are more checks to automate than can possibly be written, as demonstrated by my analogy, which you have to accept for it to be valid, but you get the idea. Some things are too difficult to automate effectively. There are some things that a human can do very quickly, and to actually write the automation for it, there's one that I had in telecom. The automation could create a graph over distance and the amount the signal attenuated of a phone line, and a human could look at the graph and the old version versus the new version and say very quickly, usually within a few seconds, that's okay. We thought about what we would have to code to have that happen, and we estimated it would have taken months, multiple months, and then we would still probably need to check it. So it just doesn't make sense to automate everything. Investigating reported failures takes a long time. So every time your UI automation fails, somebody needs to go and figure out why. The automation at the UI level tends to be very fragile compared to unit test, and it breaks when code changes a lot. And if you're not investigating the failures, if you get into the situation like that large insurance company where 40% of their tests are failing every single execution, that's a lot of investigation that needs to happen. And if you're not investigating it, then why are you executing those tests? The last one is the cost to build and maintain the automation. There's a high cost to value ratio. The value of automation is not super high. It can give you a good sanity check, as I said at the beginning, but it's not going to explore. It's not going to find bugs. It's not going to go looking for bugs. It's going to do the exact same check over and over again, and it will find mistakes that your developers have made that cause the old stuff to not work, but it's not going to find existing bugs. There's also the sunk cost syndrome. The insurance company that I was talking about did not get rid of their automation because they had invested so much into it, even though it wasn't really providing them value. So a better solution, running late, automate as much as possible at the lowest level. So unit tests, API tests, they can create them, and they're far more, developers can create them. They're a lot more reliable than UI tests. Get your business logic down at the lower level, collaborate with the developers to make sure they're doing it. Look at mini reviews. So I'll talk about that in a second. At the UI level, focusing on connectivity and not business logic, as I mentioned at the beginning. So that's weird. Must be on a following slide. When you're doing end-to-end testing, you want to just automate the critical paths, pass with the highest value. You don't want to write UI automation for all failures found in the field. Looking at the cost versus the benefit. So how hard is it to create the automation? How hard is it going to be to maintain it? And how hard is it going to be to debug it? And then actually perform testing by actual humans. Okay, mini reviews is coming. I thought I put it in a different spot. Limitations of automation: takes the same path each time. If it misses the bug the first time, it's probably going to miss it every time. It doesn't look for bugs. If you're looking in a large house, let's say there's been a robbery, and you go into the large house and you're looking for clues as to who might have done the theft. You don't know what you're looking for. It could be footprints, it could be fingerprints, it could be something they dropped. But every single time you're looking for clues, you walk into the house and you trace through the exact same steps and look at the exact same thing. So I get to the house, I dust the doorknob for prints. I go in, I look in the lobby, I take a quick glance to look for a hat, as an example. I go into the living room, I move a pillow and I look behind it, I put it back. I move the curtain out of the way to see if the window is broken, I put it back, and then I go into the kitchen. And the next day I go and I do the exact same thing. Am I going to find any more clues? No, I am not. I'm not looking for bugs. I'm checking that there's still nothing of value in those places, or nothing out of the ordinary in those places. But I'm not ever going to find new bugs. So their automation is limited to just checks. It's very difficult to automate. Does a page look correct? And it so at the last company I was at, we used to make sure that the checkout had worked by looking for the words "thank you." We would check out, and then we would look on the new page that came up for the word "thank you," because if "thank you" showed up, then we just assumed that the checkout had worked and everything was fine. It might have said "thank you, you jerk," and it might have displayed a picture of I don't know, a dog or something, and had nothing to do with it. But as long as it said "thank you," our automation would pass. So something that I think teams could consider to do to get better unit test level coverage. One of my customers had a 1 to 2 hour long meeting at the end of every sprint. They walked through every story, kind of like in a reveal, but this was within the team. They also walked through every unit test. It allowed the entire team to provide feedback, identify the gaps, they learned from each other, and they shared their good ideas. So essentially, the entire team was writing better unit tests. The tester was involved to be able to say, hey, maybe you need to consider this, or I think you might have missed this. And all of the devs then would be able to learn from each other and bring up the level of the people who were not as good at writing unit tests, and help out the people who were writing bad unit tests. And it could be expanded to include walking through the API and UI level tests if you had somebody on the team who was writing those level tests, that level test too. And that way everybody would know. And if you have someone who's writing API and UI tests, it's very helpful to see and understand what unit level tests are happening, so you can focus your UI and API level tests on things that aren't already being covered. And that is it. Thank you very much.
Yeah. Hi, Paul. That was an amazing session. Just a lot of good feedback, but no questions. That's a great thing.
Oh, here we go. When can we say we achieve full test coverage? Never. Never can you say you've achieved full test coverage. The reason is it is impossible. Kem Kainer dubbed it. He wrote the book Bad Software a long time ago. He was also a professor of software testing at the Florida Institute of Technology, founded the Association for Software Testing. So that Kem Kainer. And he wrote an article on the impossibility of complete testing, and essentially saying it's impossible to test everything because we can't be aware of all of the things that could possibly happen to the software, how it's going to interact, what might happen, what corruption might happen somewhere along the line, or there's a hard drive failure that causes a bit corruption on your disk, and that causes a cascading failure. There's just too many things to be able to determine that we've tested everything. So we can never get 100% coverage. We can never test everything. The best we can hope to achieve is that we feel fairly confident that we have caught the bugs that our customers are likely going to come across. Can I be assured? No, I can't, because I'm not a QA, I'm a tester. So I can never assure that we found it. The more we test, the more comfortable and confident we feel. The more failures you've experienced in your testing, the more things you've seen, the more likely it is that you are going to look for those types of things. So the way that you can get the coverage you're looking for is to use your experience, to use your creativity, to brainstorm with other members of your team, to try to say what could go wrong, how can we test to see that if that thing that could go wrong happens, and then things to try. What might our good customers do by mistake, and what might malicious customers do on purpose? So if you haven't tried pasting 5 pages of a Word document into your password field, because I've done that, I thought I had my password in my copy buffer, but it was 5 pages of a Word document, and I pasted that into a password field. I've also pasted multiple pages of a Word document into a command line interface on a Unix box. That didn't go well either, but it didn't crash, and that's important. It doesn't mean that your program needs to handle the 5 pages of a Word document into the password field, but it needs to not do something that's unacceptable. So no data corruption, not going to crash. It's not going to cause some unsolvable problem. If it pops up with an error message or says something a little confusing, not too big a deal because it's something really bizarre. But you also don't want to potentially cause an input buffer overflow, which suddenly now you have access to things that you shouldn't. So you can never say you've achieved full coverage, but by showing the areas that you've tested and how that was my 50 minutes right there up. And showing the coverage, the level of coverage you have. Honestly, if you get the lighter orange and yellow coverage with a couple of light greens, you're probably at a level that would be good, even for like a banking application or something like that. Probably less on the orange and more to the yellow and green. So that's that answer. And I did see Ratty had a question, when can we say testing is enough? My favorite answer to that is actually not answering the question, but switching the question around to the person. So I had a boss once when I was in telecom, and he said, hey, we've had this new release. It was a firmware release on a chip that we had on our hardware. And he said, there's a new firmware release coming, and my team was in charge of testing it. And he said, how long will it take you to test that firmware? And I said, hey, how long do I have? And he said, well, you're the test manager. How long do you need? And I said, you're the release director. How long do I have? And then he cursed at me, which I won't repeat here, but essentially he said, stop effing around, in front of an entire room of my peers. And I went, oh, whoa, I'm not trying to be a jerk. I honestly can test it in 2 days, or I can test it in 2 weeks, or I can test it in 2 months. If I test it in 2 days, it'll be a quick sanity check. If I test it in 2 weeks, it'll be a normal level of testing. If I test in 2 months, that's our deep testing, the most testing that we've done on any release. And he said, I'll take the 2-week version. And I said, I'll be done in 2 weeks. If he had said 2 days, I would have been done in 2 days. If he had said 2 hours, I would have done something in the 2 hours. So how much testing is enough is not to be determined by the tester. It's to be determined by the stakeholders or the team in general, or whomever is deciding that time is up based on the information you've provided. So I have had instances where I asked for more time, or when I was a test director at Metadata, we had a brand new thing that was coming along, and my test manager kept saying, it's so full of bugs, it's so buggy, we can't release this. We're dealing with medical data, it isn't working. And so I said, well, how much have you tested and what are the outstanding bugs? Well, she said the latest release that claims to have all these fixes was only dropped yesterday, and they want us to finish testing by tomorrow. And I knew we needed about 5 days to get an adequate level of feeling as to if it was working and if the bugs had been fixed. So I said, okay, draw up the coverage that you could achieve in 2 days, and then color code it using that same legend, and then So that's the actual, if we decide that that's all the testing you can do. And then say if we got 3 more days and if we got 5 more days of testing, what would the colors look like? And so we did that test report. It was from a different company than one I showed you, but the concept was the same. It still had similar components to it. And the chart that we had was the actual coverage achieved, and it was mostly red. It was really not a lot. We had some dark orange, and the rest was mostly red. And then we said in 3 days, it shifted a lot more to the yellows and lighter oranges. And then in 5 days, it was a lot of light orange, yellow, and a little bit of green. And so we presented that to the product owner, who had said, and the VP of development had said in public in front of the CIO, we are not slipping. And the product owner was saying, we are not slipping. And then we gave them the test report that said, we haven't tested anything really to any level, but it's your call. You want to release it. And so now, because they had seen physically right there that what hadn't been tested and what it would cost time-wise to test better, we said, you can release today, or you can give us 3 or 5 days. And the product owner overrode the VP of development and said, we'll give you 5 more days. So that's how you can tell when you've done enough testing. Not you, it's up to others. You'll have a feeling as to what you need to do at minimum, but after that, so essentially acceptance criteria. Once you've done the acceptance criteria, okay, anything else I do is gravy, but here's my test coverage and it's looking really dark orange and red. If you want me to do more testing, I'll change the color, and then you tell me when the color's good enough.
Got it. We don't have any other questions, I think. That were some great answers by you, Paul. Really interesting. So, thank you so much for joining us today, Paul, and doing this webinar with us. This was amazing. The insights that you shared, the little bit stories that you shared right now, like everything was great. So, thank you so much for doing this with us. So, thank you so much, everyone, once again. Have a nice day, and we'll meet in another event soon. Thank you, and bye.
Thank you very much. Bye.